Deephaven community team, January week 2, and we are here with another demo for you. And first off, we have Cristian showing off some stuff with the CDC. Take it away.
Hello, everybody. So last week we looked at CDC, change data capture events coming from Debezium to Deephaven, and we were looking at raw events. This week we have one step further, which is actually recreating the table from the events. The event themselves only show changes to tables. So if you were to look at the data, and we did a little bit of that last week, you see rows added, rows modified, rows deleted. And now we're going to see actually tracking a table from the CDC stream. So we have some new support in Deephaven for that. So I'm going to share my screen. So we are in main. This is already merged by now. The Debezium demo directory is the same one we saw last week. We're going to run Docker compose here in this directory, similarly to what we did last week. Couple of things to start. There is a MySQL database underneath with some tables that get created by a script that runs from another Docker image. And we're going to take a quick look at the table so that we can remember what was there. So this is a simple e-commerce simulation for an e-commerce shop. We have 3 tables: users, items, and purchases. And this is SQL, and we have a script that generates updates, right? So we're going to see purchases showing up, rows are going to be added. So with all this running, I'm going to start Web Console. I'm going to import this new model called Consume CDC. Similar to Consume Kafka, but Consume CDC, it actually uses the other one. And what we looked at last week was loading the events in Kafka. And we had to type a relatively long command for doing the consume to Kafka, giving all the parameters. So now in the Consume CDC model, we have an easier way. There is a consume raw to table. The raw part means that we're going to be reading the raw events in this case. So I'm essentially going to show you the same events that we looked at last week in this part, but it's an easier way to get to them in case you want to do something with them. You can still look at the events in case you want to build some other table based on them, right? So we can still do that, but in an easier way, configuring just these 3 arguments for Debezium configuration, which is server name. This is the name of the Docker image for the machine where this is running, the database name in that machine, and the table that we want to track. So we looked at this like we already. If you remember, there was a before nested column for each one of the columns in the table. So we have a user ID, item, status, quantity, purchase price, right? And we can see here those same columns for before and after. This is just the event. We don't have before, we only have after here because data is being inserted, and new rows are showing up here every 2 seconds. If you look at here, 71, 72. So now for the actually new part, right? Now I'm going to do the consume to table that is not raw, and this is actually going to recreate the table itself. So now we have just the columns for the actual table in MySQL, and we are tracking the changes to the table. So we also see new rows showing up here every 2 seconds, 84, 85. We don't have any deletions actually happening, but if there were deletions, this live table will actually track that too. So that's it. That's them.
All right. Very cool. Next, we have Devin showing his work with the custom type plugins.
Hey, everybody. Can you hear me?
Yep.
Great. Go ahead and share my screen right here. So we've got a new server feature that will allow users to install custom plugin types. So the user can run some code on the server and fetch that data back in whatever defined format they want. We've actually got a couple of alpha plugins that will eventually be publishing more fully, but right now they are very alpha. One is a matplotlib plugin, and another one is a JSON plugin. So I'm going to show you kind of what that looks like. So I've got a sliders.py file here that I want to run on the server, and I just want to briefly run through it. The whole idea, at least for the JSON plugin, is to be able to present structured data to the client. So typically, with the native Deephaven API, you basically have access to variables that are tickets. But with this, you're able to define some format that maybe your client knows how to ingest. In this case, JSON is a very common format that a lot of clients know how to ingest, and so we'll be structuring something like that. The specifics of this query aren't too important, except that we'll note that it's a function, it's taking in some values, it's making some input tables, it's doing some filtering, it's creating a plot, it's creating some metadata, it's creating a matplotlib figure, and then it's combining it all into a single JSON node output, and then giving us some keys and values for that JSON. And then based on this parameterization, I am invoking it twice, creating slider 1 and slider 2, giving it slightly different parameters, a different name, different min and max, and a different asref, which is important if you want to recursively resolve JSON nodes or not. The reason why I'm calling it a slider here is because I think it plays well with clients who might want to have programmatic widgets. You can imagine a client who knows how to render input min or an input max as sliders, for example, that control an input table. And then they know how to display the output table or the output figure or whatever else might be packaged up in that format. So I'm going to go ahead and run this right now. I'm going to execute the script with the sliders. Hopefully it all works there. And there we go. We see we've got a JSON node coming back named slider 2 and slider 1. So part of the new functionality is this fetch object RPC that we have where we can fetch objects. And we expect this to be JSON, so I'm going to format the output pretty. But there's also going to be some additional output too, so we can see what that looks like. So there we go. We fetched that node. It's just telling us what the size is here. And then we have a bunch of exports that we can further fetch if we needed to. So the first thing that we exported from our object was a table. And then we exported a figure, and then we exported a matplotlib figure. And that's what these type and index things represent. So if the client was parsing this, it would say, oh, we've got a table at index 1, and to refer to that, you can get the information from the parent structure. So here is the rendered message for the client. And we didn't have to have any server-side code besides the plugin architecture to support this. We can do the same thing for slider 2. It has some slightly different parameters. One thing to note is this has an embedded JSON node because I said not to recursively render this one, but you'll see we've got an access to another structured object from our client that we can maybe eventually use from the web UI, or applications could define their own formats that they want to serialize to their own clients in whatever format they want. It doesn't have to be JSON, but it's pretty to look at. So that is that demo.
All right. I'm looking forward to consuming that from the UI for sure. All right. Next up, we got Jake showing off the RSS Reader he's been working on.
All right. Hello, everyone. Let me present my screen. All right. Can you all see my screen?
Yep. Can you make the font just a little bit bigger?
Yes, I can zoom in.
Yes.
There you go. Is that better?
Yep.
Awesome. All right. So previously, I showed a simple RSS reader that just looks at one or two Reddit feeds and takes that data, puts it in Deephaven, and does some sentiment analysis on it. So we decided to expand that further and look at, instead of one or two feeds, up to 1.3 million feeds. and see how Deephaven handles that. So before I go into the tables and stuff, I want to talk about how I set this up because I think it's pretty cool. So each RSS or this podcast feeds table is built off of about, I think, 10 or 15 other tables, and each of those tables, or the subtables, have their own thread that is reading from a subset of the RSS URLs that we are looking at. So as you can see right here, there's just a constant steady flow of data coming in. Right now we have over 110,000 rows coming in. We've read from almost 5,000 URLs, so got a ways to go before we reach 1.3 million. But data's coming in, and once all of the RSS feeds are read, this reader actually goes through all of them again. And if any new podcasts or any new publications are found, then that is also added to the table. It uses the date time of the publications to determine if it's new. So if it's a newer date time than the last written one, it'll write it. Otherwise, it just skips it and continues on. So that's sort of high level how it works. It's pretty cool to stress Deephaven to not even close to the limit. I wanted to say the limit, but I don't think that's true. Just to see how it works in a multi-threaded environment, because RSS feeds are, at the end of the day, just HTTP requests, and HTTP requests are slow. So you can definitely want to use threads to read from them. So with all this data coming in, we can look at it, using Deephaven. So I have a couple other tables that were built from some very simple query updates. So if we wanted to look at some, longer podcasts, we can say, okay, what are some podcasts where our duration is more than, an hour, or whatever number we want to see. And we can see, again, this is also being updated as we get more data in. Or if we're interested in a specific author, we can say, okay, I really like this one podcast person. What are some podcast episodes that this person has created? Or if you're more concerned with data coming in real time, you can say, hey, I just want, what are the newest podcasts? What are stuff published in the most recent day, for example? And that's what this query is doing. And just as one last example, you can do some keyword matching. So I looked for, I noticed there were quite a lot of podcasts around Christianity. So I did a simple search for some keywords based on God, Christ, and Spirit. Those seem to be relevant for what some sort of keywords of what a Christian would be interested in. So we can just look at some of those podcasts and see what else is out there. So yeah, just a quick little demo. I thought this was pretty cool. Let's see how many. We're at 6,000 now, so still got a ways to go. But yeah, I thought this was really fun to work on, and I think it's a cool showcase of what you can do using Deephaven.
All right. Very cool. And that's all we've got for this week. So we will see you next week with another demo. Bye-bye.